Assalamualaikum warahmatullahi wabarakatuh. For this week, we go for the chapter 4, which is hydraulic actuator. So today we'll give a simple brief about this chapter, so that after you finish this video, you can try all the activities in the YouFuture platform, and you can consider that as a attendant after you fulfill all the folder 100%. So in this chapter, we cover for the two devices here. One is for the cylinder and the other one is for the motor. These two type is the type for the hydraulic actuator. Why hydraulic? We still cover for the fluid. Now we go for the introduction. Actuator is actually a device. You can consider also as a component. This device used to provide power, and the power will support to the work at a certain location. So actuator can be classified with respect to the motion. For the hydraulic motion, the motion used in the linear motion is the straight line. Linear motion is a straight line. It's a provide a push or pull force to move along the hydraulic cylinder. And for the rotational motion, the result for the rotational motion is this one, torque. This torque will drive along a rotary path. So this is type of the cylinder, and example for the motor. This one is for the push and pull, and the other one is the hydraulic motor, rotational. This is linear, and this one is the rotational. Okay, so we go for the hydraulic cylinder first. Hydraulic cylinder are go here. Hydraulic cylinder are the hydraulic system component that convert fluid pressure and fluid flow into linear mechanical force and movement. It means here pressure and flow become linear mechanical force and movement. The basic hydraulic cylinder, we have three types here. One is for the piston. This is the component for the hydraulic cylinder. We have the piston rod, and the barrel. So look at the figure here. This is our chamber. Yellow one, this is our chamber. Alright, and this is our piston and also our barrel here. This one, piston and barrel. Piston, barrel. Alright. Okay, now for the hydraulic cylinder, there are two types for the hydraulic cylinder: single acting and double acting. How we want to differentiate between these two? Here. For the double acting, you have two ports here. And for the single cylinder, you just have one port here. This is the basic image, the real picture of the hydraulic cylinder. So actually we can differentiate these two, double and single, by using the symbol. The symbol here, if you can see, you can see this one, just one port here. Alright, so we go first for the single acting hydraulic cylinder. This is the simpler type of the hydraulic cylinder. How it works is usually use the outside force. What is the outside force? Like this one. For this one, it use some of the load here. Okay, single acting cylinder exert force either extension and retraction. Before this, we call it as a pull push linear motion. In this one, usually we use the words of extension and retraction. Extension and retraction. There are required an outside force, this one, outside force, load, to complete the second motion. It means here, the first one, for the single hydraulic cylinder, the first one, the fluid will push the barrel inside the chamber. But how you want to push back the barrel outside to the other side of the to the other side of the this one force. It will use along the load here. Okay, now operational fluid enter the blank end of the piston here, this one, and push the piston outward. It will going up from inside the barrel. It will going out, so the fluid will enter here at the blank end of the piston, and the barrel will and the piston will going up. So how you want to retract back? The retract back by gravity or compressive spring, like this one, using this load. So after it retract to this one, they can go back to this side by using this load, and it will going down. For the double, we have 2 port here. Okay, but for the double acting hydraulic cylinder, since you have 2 port here, this 2 port will allow the fluid enter. Fluid here and fluid this one. Alright, so double acting cylinder generate force during both extension and retraction. Still linear motion, extension, retract, extend, retract, extend, and retract. Directional control valve will use to opposite side of the piston. This one you will learn DCV in chapter 5. What is directional control valve? So force output varies between extension and retraction. How is operate? Fluid enter the blank end of the piston. This one. If the fluid enter in here, it will fulfill all the barrel inside here and will push the piston to this side. Then after we want to get the barrel piston to this side, we'll use this another port. The fluid will enter here and the piston will go to this side back. Okay, this side, and the fluid will go out and the fluid enter to this side and the piston will go to the other side. This is how it works. Okay, 2 port here for the double acting cylinder. This is the application of the hydraulic cylinder. This is your hydraulic cylinder. Example of the usage of the hydraulic cylinder, and this one, if you can see, it is this one, hydraulic cylinder, and also this one. The motion is up and down, linear motion. Push, extract, retract, extract, retract, push, pull, push, pull. Okay, this one also. It will connect to the tank here. From the tank, the fluid will support will go to the hydraulic cylinder here, 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 and here. You can see there are hoses to supply the fluid from the tank. Okay, this is also some sort of the type of the cylinder. Here, one motion. Here, linear motion also, and this is the mining here. Alright, and also the agriculture. construction also, and also for the oil field, aviation also. Okay, now for analysis, how we calculate analysis for the hydraulic cylinder. Since for the hydraulic cylinder we have extension and retraction, you can use this formula, extension and retraction. Since hydraulic cylinder produce work in the form one linear motion, force and movement, it is important to determine the force, velocity and power produced by the hydraulic motion. So hydraulic motion, it can produce force, velocity and power in terms of extension and retraction, these three. You can calculate all these three by using this formula. For the power, you just have one formula here, used for the extension and retraction. This one, the same one is just the power. The other two, force and velocity. Okay, example 1 I will show you in the next video. So we go to the hydraulic motor here. Hydraulic motor called as a rotary actuator is produce torque. Convert fluid pressure and flow into torque and rotational movement. Fluid pressure into torque and rotational rotary. So if you can see the image here, picture here is a rotary motion. Okay, the basic component consists of three. Housing, it's a housing here. You have a body casing, you have a housing, rotating internal part here, and power output shaft here will connect to the rotating internal part inside here. So the symbol is quite different with the hydraulic. This is the symbol for the motor symbol. You just only have, for the hydraulic motor, you just have one type motor symbol here, this one. Here, this one. So power output shaft will connect with some sort of the. So basic operation of a hydraulic motor. Fluid system enter the housing and apply pressure to rotating internal part. From the pressure, it will rotate the internal part. This in turn move the power output shaft and apply torque to rotate the load. Load here, it can be rotate. Primary part that produce the rotating motion in most hydraulic motor are either gear, vane and piston. So for the hydraulic motor, there are three types of the part. Primary part here for the hydraulic motor, we use gear, vane and piston. Of course, the vane is the simplest type. This is the medium, and this is the complicated or the expert, we call it as a part. Okay, we go for the gear motor first. Develop torque due to hydraulic pressure acting on the surface of the gear teeth. So it use, since the name of this hydraulic motor is gear, so it use gear part here. It can be reversed by reversing the directional of fluid flow. It means here you can rotate to this direction and also the opposite direction. So volumetric displacement is fixed. Maximum operating pressure 14 is quite low. Maximum flow rate 570 liter per minute, and maximum RPM 2400 revolution per minute. That one is speed. gear 14, sorry, for the gear compared to the 2000 and 2000. So for the vane motor, what is vane? Vane is such as like a fan. This one, vane. Vane here. It uses vane to develop torque, and also this vane will produce the pressure. This pressure will produce the torque. Spring pressure loaded vane to hold the vanes to the cam ring. So here, internal shaft will connect to the cam ring. Usually fixed displacement, same like a gear. Maximum pressure 17 compared to the maximum flow rate 950. It's quite high compared to the 950 for the 950 compared to the 570, and for the maximum RPM 4100. So now we go to higher speed compared to 4000, high compared to the, it's quite low. Also for the piston, generate torque by using piston. This piston will produce the pressure, then the pressure will produce the torque inside the cylinder block. Inline piston, this is some type of the piston motor, swash plate, and also bend axis, or we call it as an axial piston. Higher speed pressure, maximum flow, maximum operating pressure high compared to these two gear and vane. Maximum flow rate also high compared to gear and vane, and speed this rate. So piston motor have the highest speed by the this is some type of the piston motor, inline and axial. So analysis for hydraulic motor. Since hydraulic motor produce work in the form torque and rotational movement, it is important to determine the torque, flow rate and power. Compared to the cylinder, yes, is it we have the flow rate? Hydraulic, it produce flow rate and also torque compared to the cylinder. Hydraulic motor, from hydraulic motor performance also we can evaluate on the same three efficiency parameter: volumetric, mechanical, and the other one is overall efficiency. Same with the pump in chapter 3. Efficiency, volumetric, mechanical. From these two we can calculate for the overall efficiency. So this example 2 is already in the video in mock platform. You can check and see the solution there. And example 3 also you can find it in the video in mock for platform. Next, the application of hydraulic cylinder, hydraulic motor. It's so simple. Hydraulic motor is a part of hydrostatic transmission system. Consists of the basic component typically found in the other hydraulic motor circuit, such as tractor, roller, front end loader, hose, and lift trucks. So if you can see here, hydrostatic drive provide effective transmission. Power allow easy adjustment and control of, you can control the shaft speed, torque, horsepower, direction of rotation. Compared to conventional transmission, hydrostatic drive high power output to size ratio, installed under full load, no internal damage, accurately maintain speed under varying load, and provide almost infinite numbers of input and output speed ratio. So this is the end. You can also see here some of the summary of the analysis for the cylinder and motor. The rest of the slide you can see, and you can try all this the performance in the tutorial. Don't forget to submit the tutorial in the Padlet. If any question, you can text me. Thank you, class. Assalamualaikum.